Welcome back everyone to lecture on engineering mechanics. Myself Krishnan. In this lecture, we are going to see how vectors can be added using cosine law. Basically, cosine law is applied for two forces acting at the same point. Let us consider a force P acting like this. Let us consider another force Q which is acting like this. We want to find the resultant of these two forces. The resultant would definitely be lying between these two forces. How do I arrive at that assumption? Yes, it is very simple. I just have to construct a parallelogram using parallel lines to the given P and Q. Now, the angle between these two forces is given to be theta. In that case, how do you find the magnitude of the resultant force R? The magnitude of the resultant force R can be written as R is equal to square root of P square plus Q square plus 2PQ cos theta. You will see different forms of this again as P square plus Q square minus 2PQ cos theta, which is nothing different, only the thing is that it is the angle definition that gets changed. If the angle, that is say alpha, is available to you, then the resultant, the magnitude of the resultant R would be square root of P square plus Q square minus 2PQ cos alpha. This is how you are supposed to use your cosine law. Based on this, let us try solving this problem. A cable stays A, B and AD help support the pole AC. Knowing that the tension is 120 kN in AB and 40 kN in AD, determine the magnitude and direction of the resultant of the forces exerted by the stays at A using the parallelogram law. So, here what we have to see is that we need to find the angle between these cables and the pole. So, to find that, let us take a simple trigonometric function here. Let me define this angle as theta 1 and let this angle be theta 2. Theta 1 can be expressed as tan inverse of opposite side by adjacent side. So here the opposite side is of the length 8 meters and the adjacent side is of the length 10 meters. So it is tan inverse of 8 by 10, which is equal to tan inverse of 0.8, which is approximately equal to 36.66 degrees. Similarly, theta 2 is equal to tan inverse of 6 divided by 10. Again, the same principle, opposite side by adjacent side, 6 by 10, which is tan inverse of 0.6, which is 30.96 degrees. So, we have the angle between these two vectors now. How to find the resultant magnitude? Now, resultant magnitude, let us write the equation. The magnitude R is equal to square root of, let us define the force vectors here. This is TAB, this is TAD, and let this be the resultant R, which is need not be acting along AC, but it is resultant R. It is not given that the resultant is acting vertically downwards, so you can use any of these direction as R. But the angle theta 1 plus theta 2 will remain the same, and this will be theta 1 plus theta 2. I can say the resultant R magnitude is equal to TAB square plus TAD square plus 2TAB TAD cos theta 1 plus theta 2, because that is the angle between these two vectors. If you substitute the values one by one, here it is given as TAB is 120 kilonewton, TAD is given as 40 kilonewton. So square root of 120 square plus 40 square plus 2 into 120 into 40 into cos of 67.62 degrees. Whole thing under the square root, which is equal to 140.2 kilonewtons, because all the forces were in kilonewtons, so we are going to use that. Now let us come back to the cosine law again. Here, if I want to find the angle at which the resultant R is acting, say this angle is say beta. How to find the angle beta? The formula is simple. Beta is equal to tan inverse of Q sine theta divided by P plus Q cos theta. Okay, so if you want to have a better understanding of this thing, let me just redraw the triangle. Let us consider the force P first. So I am drawing P here. P is the force, and I have added Q to it. Q is like this, Q, and the resultant force R is going like this, R. Now if I try to finish the triangles of P and Q, I get it like this. Okay, now here is where my triangle I am going to slightly modify it. Let me just extend this line of action of P such that I drop a perpendicular from my resultant endpoint R. So from this point I am going to drop a perpendicular onto the line of action of P. So this angle is 90 degrees. Now if you look at this triangle here, Q is the hypotenuse for this right angle triangle. So this will be nothing but Q, and this angle as defined is theta, hence this angle is also theta. So if you look at it, this will be Q sine theta, and this edge will be Q cos theta. So if I want to find out this angle, say beta, it will be the tan inverse of opposite side by adjacent side. Tan inverse of opposite side by adjacent side. So tan inverse of opposite side is Q sine theta divided by adjacent side is P plus Q cos theta. So this and this, they are the same. So with that, let us try to do this problem here. So let me take, instead of P as TAB and Q as TAD. So in that case, I'll have my angle, that is the angle with respect to AB, let me define this angle as alpha. Alpha is equal to tan inverse of Q I am considering to be TAD. Okay, TAD is going to be my Q and TAB is going to be my P. That means TAD sine theta. Sine theta would be 67.62 divided by P is my TAB plus TAD cos 67.62, which will come out to be approximately 15.3 degrees. So we have the vector resultant vector R as R is equal to 140.2 kilonewton acting at an angle of 15.3 degrees from TAB. That is very, very important. From the force TAB, it is measured 15.3 degrees. So with this, I think you will be able to understand the cosine law. Thank you for your patient listening. I hope you are able to follow my lectures. Please leave your feedback in the form of comments in the below section. Until next lecture, it's me signing off.